Now we want to look at graphs of composite functions. Now we've been looking at some of these in class and through some of our examples and past exam questions. So what's a composite function? Well, basically it's a situation where we have a function that is a function of a function. So e to the power of cos x. So you got, instead of e to the power of x and graphing that, we're taking the values of cos x and then putting e to the power of those values. So to do that, what we need to do is consider the function cos x and then put it together with e to the power of u. So there's our two functions separately, e to the power of u and the functions there. So what's important about this one? Well, obviously when we're looking at e to the power of u, where x is equal to 0, we know y is equal to 1. So when we're looking at the values there, then that's going to be pretty critical, because every time it goes through 0 on this, on cos of x, e to the cos of x will go through 1. Also, we need to consider, well, the lowest value is minus 1, and our highest value of cos x is 1. So our function e to the u is not going to go below e to when situation at either minus 1 or e to the 1. So when we graph that up, what does it start to look like? Well, we start to get this situation. As I said, whenever it was 0, it becomes 1. So we get that situation there. So e to the power of 0 was 1. Right, and e to the power of 1 becomes e, and e to the power of minus 1 is 1 on e. So that's going to be our lowest values. So you can see that with pi was 1 on e, pi on 2 was 1, 3 pi on 2 is 1, 0 is e, and similarly. So you get that same shape occurring as you go through. So that's what we've got to look to do, is again consider those critical points in both the two functions that we're dealing with. Graphs of 2 to the power of minus u and u being equal to the absolute value of x. So to graph 2 to the power of minus x, well, we've got the two of them there. So what do we get? So there's the absolute value of x, 2 to the power of minus x. So again, we consider that situation where it's going to go through the axis. So 0 gives us 1, and 2 to the power of 1 would be 2. So we know it's going to graph at 2. Because of the nature of the values here, they're always going to be positive. So we're only dealing with this part of the curve here, really, because that's where we're going to be throwing in positive values all the time. So the highest value you're going to get is when x is equal to 0. Absolute value of 0 is 0, so it's going to be going through at 1 there. So when we graph it up, that's what we get. And notice it comes up to a cusp type situation because the function itself was at a cusp. And as x gets larger, the absolute value of x got larger, so 2 to the power of minus x gets larger there. So, and the same thing happens on the left hand side. Natural log of 1 minus x squared. So what is 1 minus x squared?